And we're live. Hey, hello everyone, and welcome to another Data Science Office Hours. Uh, Tonight will only be Terry and me. All of the other guys are just sick or having some troubles, but
Good
be with
morning,
us
everybody.
next week.
Good morning, everybody from Europe and Fab. Thank you. Awesome to take all the effort to set it up. Yes, it's just the two of us. So the great thing is we you get to hear a lot from both of us, and we both fortunately talk a lot. We love talking, so you're gonna have a good time here for this whole hour.
Yes. So we have a lot of things to say to talk to you. So maybe first we'll talk about and we'll mention some techniques for data preparation. That was the topic for today's session. And after that, we'll get into questions and more stuff with you guys. So I'm gonna start off this this session by saying first, thank you again for being with us, and we hope that these sessions will guide you through the process of the pipeline of being of working in a data science project. I know every organization or company is different, but luckily we have some points in common. Like you have to prepare the data, explore it, study it. So we're trying to focus on that first. So
Awesome. Yeah.
data
I
preparation.
guess.
Why remember last week, 2 weeks ago?
Go
Yep.
ahead.
So if you remember 2 weeks ago, we talked about defining a problem in data science. That actually led us to a really good discussion on what is a problem in data science, what is not a problem in data science, how to approach that, how to learn from business to get into solving a problem in data science. And there's been several posts since then that talked about that, both from us and from your side too. So that was really awesome. And thank all people that created all of these repos and stories and blogs, because that's really helpful for us. So right now, first I'm just gonna say some words, and then I'm gonna have a conversation with Terry just about data preparation.
Sure.
So first of all, why would you prepare data? This is a the question here. Why would you need to transform or prepare data before or after or during a data science pipeline? And I think we all can agree here that uh, normally when we are in real world, data is not clean, data is not perfectly shaped, or data is not what you expect it to be. So there are a lot of different techniques, a lot of different kind of approaches, depending on which data do you have, on how can you transform or make that data better for both study and then for modeling. If you remember, one of the main sayings here in data science is garbage in, garbage out. So if you are not using the correct data, or you're using data that is in a weird format, or that the model is not expecting that to be in that format, you're just throwing anything into that the model or algorithm or framework, and you're gonna get nothing in the end. Or maybe even worse, you're gonna get wrong answers. And when you're a data scientist, you have to provide value and veracity to the company, because it's not only solving a problem just by solving it, it's solving a problem using real data, and and solving the questions that the all of the company have by using real data that will then lead them to make decisions informed on what will happen in the real world, not what happened in your experiment or test or weird format data you had in that time. So Terry, what do you think is the first step on going from raw data into just thinking about transforming that?
Um, First of all, yes, I agree. Having as much data, especially when you're looking at supervised, let's say, in machine learning, supervised or unsupervised, I think the wisdom still is in the industry, and for good reason, uh, to improve your accuracies and to reduce your cross entropy cost and losses. That the more data you have, the better it is. So I think, if you're asking me why you need data, I think, it is definitely a no-brainer that we need more data to be able to arrive to the ground truth label, which is what our goal is, right? Um, and I think it's very important. I guess you guys discussed last time. I wasn't here, about identifying what is the problem that you want to solve,
Yep.
and is it a problem of classification? Is it a problem of clustering? Is it a problem of regression, ranking, or any of those things? And those are kind of really important things you need to do in order to have your algorithm answer a binary kind of answer, like yes or no, right? So, and I think, there's a whole lot of work that needs to be done. I can tell you a project in which, and there are a bunch of projects that I'm involved with, and the first question is, do we have the right data, and do we have, uh, you know, is how much richness do we have in terms of the heterogeneity or the homogeneity of data? Collecting as much as data today, fortunately, it's great, because uh, I cannot imagine, like 15 years ago, when I was managing, large data warehouses, we were just looking at really sparse data and arriving to conclusions. And people also believed me, to be very honest, because they said, okay, he's the database guy, he's the guru, and let's just believe him. But deep down inside, lack of data or availability of data made me also realize that, well, how rich is my analysis, or whatever the results that I'm giving to my management. Today, fortunately, in any or every area, you can literally collect a lot of data. For example, one exercise, one project that I'm doing with several medical colleges is about, uh, cancer detection, etc. What we realize is that today, with basic sort of techniques, you can simply create a very sort of simple sort of a scraping file with Python or any other programming language. It really doesn't matter. And you can actually get a lot of data and start collecting those data in the repository, which is obviously still in the raw format. You need to obviously, move into, like I said, in articulating, what am I doing here? Do I want to go further than just classifying that it is skin cancer or not? And what do I do then next? Do I need to cluster? Do I need to kind of, is it, the single input as to single output? Then do I need to use a sequential model if you're using Keras or whatever? Or what happens if I want to use an API within Keras or, again, any other platform, in order to have multi-input and multi-output sort of class labels? So the more data you have, you can start thinking of, moving into clustering and start clustering, because the problems are always in clusters. The only thing is, we start out small. We look at that, that single sort of one input, and I want to know if it's a yes or no answer, because we are limited with the amount of data which we do not have, but we have unlimited questions which we need to be having answered, right? There are like 17, 20 classes in skin cancer. Well, that means, wow, there are like a ton of input labels I have, and there's a lot of sort of output that I can have as well, which can provide a great foundation for, let's say, your inherent problem or that project, or that, you can create, this is your do-it-yourself project kind of solution. And so to me, I think, the accessibility of data, is making a lot of things possible for me, at least. This is really interesting, and I can very clearly see, it's also not just, I think, for people who are listening, is this very important. And I said that also in a workshop. So this is something which, we're not, me and Fab are not thinking out of our head. We see it every day in our daily life. It's very easy to see that people who are able to gather more data have, with the interesting results. They are also starting their own companies from just simple basic ideas. So there's this company raised about, like, I don't know, 5.5 6 million euros with their app. They simply developed a very simple solution. They created, and they are right now raising capital. So I think the possibilities are tremendously endless if you are, data scientist inside in your own company, or if you're just two bunch of PhD or whatever students thinking of a great idea. It could be brain vessel segmentation or something else, brain tumor segmentation, stroke analysis, or anything else. You could really come up with a solution with enough data, but there is sparsity, which I also want to say something, and just then I'll stop talking. So the sparsity is something meaning having less data, and you just don't have more data. So that is the truth. That there's not been enough tests done in this area. We are not able to create, no need to create dummy data, because you want to have really, really verifiable and veritable truths. In that situation, I think new techniques are coming in, which is super exciting. I mean, in capsules, where I'm not going to talk about regularization, there are some interesting things that are happening in the machine learning and deep learning industry. So we know L1, L2 regularization. People know about that. There's an interesting paper with Derek Kingma wrote on L0 regularization, just recently wrote. So I just reached out to him yesterday because there's an interesting project we are embarking on with capsule networks. So long story short, yeah, I think having data is crucial. That is unknown. We have no arguments there. Understanding which avenue do you need to go to, and articulating where exactly the problem you need to solve is key. Like, classify, segmentation, clustering, regression, etc. So I hope this answers the question.
Yeah, that's that. I think those are really amazing points, and this is cool because people is. I mean, I think one of the things we're trying to do here is because we work in really different industries. I work with banking, and Eric works with LinkedIn, and you work with all of these kind of organizations like health and stuff. So I think is really important to see here that even though we work with these amazingly different organizations, we still have to do the same things every day. We still have to look for the same kind of problems we're trying to solve, and trying to figure out which data do we need, and how we can transform the raw data we have from the data we need actually. So one of the things that I think is really confusing to people, because I was confused some time ago about this, is so I think we have an idea on how to transform or prepare data for machine learning. When I say that, it's like, I want to work and create a model that classifies if a text is a positive or negative. And there are these steps where first you need to clean the text and find a topic and everything like that. But what about deep learning? What about how can you clean data with deep learning? I mean, maybe what if you have images? What if you want to recognize pattern or objects in your image? Well, are there steps that can you mention to people on how can you use different techniques to clean or prepare data for deep learning for this kind of computer vision applications?
Yeah, interesting question. So in healthcare industry, where I am having a lot of conversation, but that's irrespective. You could be in a, you could have a startup or some idea on autonomous driving. I think collection of data, it depends in any and every different situation. For example, if you're a warehouse company, or if you're, let's say, if you're a hyper local food startup, and in all over the world today, we have people who are managing this information. So deep learning. So sometimes you're combining time series data with your indoor or warehouse data, meaning you have images, and you also have time series data in which you're trying to bring in those, like typical any other FedEx or DHL. the last mile, kind of improving your margins and making sure that you're delivering on time, and every single second counts. So sometimes the problems are more complex. You need to break them down into, so I have this problem in my data warehouse. What are the things that I need to do? Now, today, if you see, for example, Amazon and other companies, that you've seen those videos, right? On the robots, moving around, those little robots they carry, lifting up stuff, moving from place to place within their warehouse to improve inventory, and stock optimization and those kind of things. So it's super important to have the shelf value of the product that is there on your shelf. Now, there are new questions I'm hearing from companies. So there is a founder of a company. They've just raised a few hundred million. I think last year raised about $100 million dollars or euros of capital. They want to be the best in class, and far away from all the competitions in the fresh food delivery kind of concept. Now he asked me a question like, "Hey, listen, I have a huge warehouse. We're thinking of using drones to, they all fly in the same direction, and then they go back in the same direction, and then we take a lot of pictures, and then we try to start optimizing and creating a huge amount of data set, because then we can have information on how our products are optimized in their shelves, and then eventually I want to use that information also into the delivery value chain, in which where people start delivering those goods and values to consumers in their regions. Now, really interesting problem to solve, but you need to break it up into subsets. For example, so I said, listen, I think the best is probably even to start positioning cameras all over, and everybody has cameras, and not all warehouses actually. So if you have cameras, then you can start using new techniques that are emerging in deep learning, for example, in indoor scene segmentation, as in being able to classify a problem within a scene. For example, right now you're sitting in a room, I'm sitting in a room, I have my dining table here, chairs, everything in relation to each other. Now there are different techniques in order to take those pictures, because there's a picture. Actually, there are pictures in pictures, right? That's what indoor scene segmentation actually concept is. Now there are many interesting ways to kind of collect data. So collecting data is you can collect huge amounts of data from that perspective. Now you take pictures and you continue to take pictures, and then eventually you start identifying patterns in those pictures based on those pictures and indoor scene segmentation. And then you start using other different kind of techniques, including people are trying to even look at capsule networks. And there's a whole lot of research going on this year. A lot of people are researching around it. No one is talking about it naturally, because myself as well, I'm not allowed to speak about some pretty cool projects that are here with the top medical schools here. Well, that is one of the secrets. And the other secret was about the warehouse, but it's an interesting thing. So I'm not mentioning the name, but I think if guys from Amazon are listening, saying, "All right, we need to pay attention." But I think the whole idea is in from a deep learning, or from, let's say, a complex learning. People these days are not talking too much, or not. It's about just machine learning. But from a deep learning as a perspective, the image collection, image classification, the dimensionality of the images. For example, you have large images, that's great, but and you have images of different sizes, unless you start organizing, taking pictures right now. So if you have everything organized in your data warehouse, you know that you can optimize images to have a certain size, 1024 by 1024, or 8096 by 8096. Like, whoa, huge image. Panoramic images and all those things. So there are many other different things coming into the market, which in the next few years you'll see videos and images and everything, all that segmentation happening in this huge space, huge, actually manifold, really, right? It's a three-dimensional, actually, or multi-dimensional manifold. And this is the manifold. It's almost like you can see, and this is how your machine is going to be able to see and identifying the relationships and the variance of objects, and also the equivariance of objects within themselves, and then in relation to others. So a lot of complex world is coming together. But basics remain basics. So whether you're looking at data which is just tabular data in text files and Excel sheets, With image classification, you still need to ensure that you're doing basic things like transposing those images, understanding, well, I have an image, and if I'm using a matplotlib or some other kind of, or any other library, if you use, for example, very simple example, if you use a plot or plt.im show, and between those parentheses, you need to be able to understand that, well, I need to be able to transpose those images in order to be able to interpret it into my deep learning. So some serious basics are very important. I teach them in that class myself. And every time I keep looking back and I try to tell myself, because these are basics, but we all forget it. We just say, take a line of code and we say, okay, it's doing things for us. Now, it is very important to understand when you get stuck in those problems is to continue to understand the fundamentals of, well, what am I doing here? So the pre-processing, collection of data, and also whether you want to, you also need to sometimes expand or augment your data in order to make things better. Flipping images upside down, flipping images side by side to make sure that you're able to use the right concept of the convolution neural network or other techniques. So I think there's a whole lot of things you need to do. The first thing, obviously, is you need to obviously resize those images to be able to put it into your machine deep learning box and start interpreting results. Now, depending on how great your deep learning framework is, in terms of you have hundreds of GPUs in a large cluster, so you're really good to go. So, from an image perspective, I think it definitely is very important that you definitely are resizing, reducing the dimensionalities, making sure that the images transposed are interpretable into your system can interpret it, and eventually those are the very pre-processing very important things to be able to format the data. Basically, you're formatting whether it's an image, whether it's a video, or as we have been doing it for, like, I don't know, number of years in machine learning, and text data, and well, in deep learning, data which is not structured, which we typically use. I'm sure you guys have just finished your network training in Coursera. So you see that there are some amazing things you can do, but with those amazing things do come complex problems like audio, video, and changing and transposing and transforming that data into some interpretable results. So I think you need to establish data collection mechanism is really, really important. I think if you have that in place, the basic fundamentals of your machine learning actually are reflected actually also in deep learning. So there's not much difference from that perspective. The only thing is, I will, however, say this, that the way, so so I've been sort of a data guy for a long time, almost 20 years. The way we've been looking at data, as whether database administrators, developers, or even analysts, we need to change the way we look at this data, which we put it into this deep learning frameworks like Keras or TensorFlow or PyTorch. Images, videos, they require a different intuition that you need to continue to sort of hone and get inside your head, gaining intuitions from how people, for example, in video, and even graphics in movies world, look at these people have great intuitions. The only thing is it's a totally different world. No one thinks about how they look at data. So I'm doing a whole lot of things, and it's interesting, and I think we should have another session in which we have that conversation as to what do these people do in taking that data and rendering and transposing and sort of understanding of using inverse graphics with images. These people are far ahead. They've been doing it for like 20, 30 years. I'm talking about people who work at Disney or Pixar. So there are some interdisciplinary kind of competencies and learnings that we definitely need to share. So we should not pretend as people in deep learning industry, which is a young industry. I mean, it just got named a few years ago, that we know everything. So I'm learning every day. And I think,
Yeah.
coming back to your question, so there is one issue of doing the basic fundamental, analysis of the exploratory EDA. All right, so this is what I want. And at the same time, try to combine it with not just your understanding of convolution neural network or any other kind of recurrent neural network, or having a convolution network and recurrent neural network kind of combinations. People are combining those two also together to apply to the problem. Also use intuitions that are coming from industry that have sufficient background and experience in working with images and video data. So I think this is definitely going to help us understand a lot of problems that today people are still looking from a very classical machine learning perspective. For example, in autonomous vehicles, just looking at a scene and trying to say, okay, something is happening, and still a car crashes. Now we don't want any car to crash anymore ever. So, but again, that is a different problem, I guess, for another session in terms of how do we optimize, what kind of algorithms and techniques do we need to use to continue to fine tune that model. I'm sure, I think there's going to be a different session. But I think pre-processing, or at least the process before pre-processing, is collecting data and then trying to sort of transpose, transform, augment, expand data. They kind of remain the same, actually. Yeah. Long answer. I
Whoa.
hope it
And
helps.
no, but that's an amazing answer. And I think this is one of the things that people are really confused, because when we start doing all of these courses on deep learning, and when the topic is, I mean, the topic is really new. So I think we're focusing a lot on applications, and that's what we normally do when a new topic arrives. But these steps, I mean, the things you need to do before trying to use this kind of research or application, those are the steps that are really hard for people. So now I really want to talk about, uh, maybe I think people may be wondering, how can I do, I mean, what can I do to prepare my data? So I think preparing data is a mix of different things, and one of those things that maybe sometimes is forgotten is that preparing the data depends on the business, and you need to understand the business before going in to prepare anything. And what is that? I'm gonna give a simple example. So just imagine you have some data for your clients, and you're in a bank, and these clients may have different kind of products with the bank, and one of those products can be maybe their account. All right. So you know that the account of a customer maybe and will probably be on a value between 0 and infinity if it's really rich. All right. What if you find somewhere, or some people that has like negative values on their account. So like just 0, or something maybe $1,000 in the bank. But for some different kind of scenarios, that can happen. But you need to know, hey, is there a limit with the bank, and that will let you have like negative amount of money on your account? Is there a limit, or is this a weird value? So this is one of a simple example that is not just, hey, this value needs to be from 0 to infinity because it's the obvious things for you. You need to ask the business, hey, what about this value? Is this value a weird thing that someone typed? Is it a typo? Or you can actually have these kind of values in this column. And those things are not, for at least for me, that I'm a scientist and I work in a bank, they were not obvious for me at all. So one of the things you really need to do when preparing data is trying to have these kind of meetings with business and ask, hey, what do you think? I just did an study of this data of these columns, and this is what I got. So I really thought that this was some weird data. What do you think about that? Is this normal? Is this really weird data? Did something wrong? And all of these techniques for imputing missing data and stuff, you really need to ask the business about that, because some people can say, hey, if you have missing data, just put the mean there, or use the mode, and because I don't know, that's normal. But sometimes you can just ask the business, and they'll say, hey, but if you do that, and we've done that before here, you can just skew all the data sets. So you really need to be aware of what you're doing. And when you're using techniques for imputing missing data, or from just trying to clean normalized data, that ensures that processes are aligned the business is really needing, and not
Yeah.
what you as data scientists want or think that is the best for the data. You can have an idea of what's the best for the data, or what's the best shape you need for the for from some data to just run a deep learning or machine learning algorithm. But if that data is not aligned with all of the rules of the business, you're just messing around.
Yeah.
So before losing time when doing that kind of studies with your data, first ask the business, have a clear mindset, and have and document all the process. This is a really, for me, a crucial step, because you can transform the data a lot, and it can be really different from where you began. So if you don't have an idea of what you did each day and each transformation is doing, then if someone asks, hey, what about this value here? What was it before? And you don't have an answer for that. And that's a problem even for the business and for you too, because you need to provide a good solution that is reproducible. And this is one of the things I've been talking a lot lately, is that data science need to be reproducible. And this is for me one of the things that will lead us to be a science somewhere in the near future. Because if we do all of these transformations and we change and reshape the data, but we don't have like a way to go back to the beginning, we're in trouble. Because what if you want to run the same study again and again and again? You will need to reinvent the things you said you did a long times. So that's not a good way of working. So document and try to get as much knowledge from the business as possible. Those
Yeah.
that could be my two big suggestions for preparing data.
I agree. Yeah, I totally agree, because it's interesting. In the banking industry, you're right. Negative value should not be seen as a negative value by data scientist who is a little bit aware of which business he is in or she is in, and trying to answer those questions in terms of before embarking on a mission to start wrangling or start playing around with the data, right? And for example, negative value need to be classified very differently or labeled differently. There's nothing negative actually. It's just something. It's something that is happening in a bank, and you have identified it as someone needs to stay, let's say, on a certain amount of money till a certain limitation. There is a threshold. Beyond the threshold, we either close the account or something happens to that person. But you need to definitely label and classify the data, or at least in when you're having your data sets prepared before you start crunching and mining those data sets, as to, well, 20% of people are always, you're answering basic questions. You should just think of answering those questions like your bank teller, or anyone who's responsible for mortgages or loans or any of the different sections within your banking, are answering those questions when they think, when they go to their customer and talk to those customers, right? So, well, 10% of those people in a region well, let's say Wisconsin. uh, I don't know. I know the Midwest area in U.S. I won't say any more words about the, in terms of patterns of what happens. But people in certain area may be low on cash, and what does that mean? So it's a pattern based on geography. It's a pattern based on sort of consumption pattern of those people, and that eventually leads them to us have being a negative account. So you need to sort of understand uh, in terms of some kind of it's not an outlier, so this is not a noise. It's definitely very useful data, but we just need to kind of label it properly. Other things about you write about inaccurate or missing data, and just trying to average things out, and it's very nice, seems very cool data sciencey, but the thing is very simple, guys. It's if you are working for a food delivery company, it could be Amazon, it could be Walmart, it could be some little startup you're starting. Just think what exactly this whole value chain of basically it's a value chain that you're trying to translate it and providing a data insight from technology perspective. So the richness of the data in this value chain of you create the product is consumed by the consumer, and he gives or she gives a feedback, and the product is recreated. So that's the iteration process you're doing when you're running business. Now let's not forget we are in business. Just being data scientists and writing nice stuff in blogs is not going to make this industry explode. We have to work to understand it. So some people are forced into dealing with the business problems. So those people become the really successful data scientists. They become machine learning leaders, AI leaders, and they are the ones who are connecting the dots from business, answering questions and saying, "Hey, wait a minute. Well, what are you exactly as you said? It's right. It's fine that you're classifying this as an outlier, but actually that was just actually a mistake, a human error by a person from my department. So, well, then the thing is, before you and that can be a big problem because you have taken that sort of situation, although it's in the back of your mind that it is an outlier, or in some situation when there's absence of data and you make an outlier out of it because you don't want to have it in your normal distribution, right? Or a standard or Gaussian distribution. Now, when do you have to do that? That it does not have an impact on your analysis for that whole subset of the data, or maybe that whole data set, then you have a problem. So, totally agree. I think it's important. So, the inconsistency of data, the noisiness of data, the inaccuracy of data as in not being available, not a number, etc., and doing simple drop in a or whatever. It's in some cases it makes sense because just before 2006 we weren't doing this operation. After 2006, when internet came and we started creating more values and there were more columns, and we started doing that stuff. So how do you normalize it? It's very important to normalize anything. Whether it's in deep learning, you need to normalize your images as well, right? You have to normalize, and it's very important to keep your eye open for why am I normalizing it, why am I regularizing it, before we start doing this whole network pass in deep or machine learning. So I think it definitely makes a lot of sense. And the best learning comes for a machine learning or a deep learning scientist or engineer or analyst. Forget about labels or names. It's about learning the things and understanding about your business, because once you become savvy about your banking business and really understanding it, you will become a leader within your bank, within your grocery chains, or in autonomous vehicle, medical industry. You will become a leader in those areas because people will come to you because you have really become that person who has elevated to a very sort of a deeper and higher level of thinking, conceptually trying to understand not just the analysis that you do, but also the impact that it'll have from your analysis, and also your future studies that you will be doing. So you will be called into boardrooms literally, and I've experienced that. People say, "Hey, call this guy," because he's. I've seen him walking around and talking in all these, coffee and water cooler, and he's been. Yeah, I like what he talks. And so the acceptance of data people, fortunately, it's improving, although it's not really. It's still the same old world where business is not really. Um, they still don't really understand. If you ask me honestly, I think it's also not hasn't improved dramatically. Tech guys are still tech guys. I used to be a tech guy, and then people don't sort of they know that you make sense, but you're never involved. But the last couple of years, it's changing. So if you don't understand which business you're in, I mean, literally, you could be the smartest person coming from an internet company because they hired you because you were popular or whatever. But if you didn't take interest in understanding and making enough, let's say, cross validation, literal cross validation with human beings around the company who have been doing this for 20, 30 years in that company, you will miss on some very crucial insights about the patterns that lead to, let's say, the convexity of data. That's what we're talking about. Because if the data is concave, as in, well, I don't know how to sort of, connect these dots because oh, wow, it's different because this doesn't seem logical with that. You will be able to save yourself from a lot of concavity problems if you have had that conversation with business. Like I said, sometimes it's just a very simple answer that, oh, gee, I made a mistake. Actually, I didn't know what to put that. I just started putting this number in it because that way I don't have to take it into analysis. It was just a reminder for me to not to do that. So then you say, wow, you know? So human insights, which are put into data, which you think and just think, oh, well, I'm going to use the data science perspective. Well, human insights will really help you understand this very well. So I think this is just
No,
another wisdom.
and
Yeah.
yeah, and I think all of that is what will different. I mean, what will make you shine, and also what it will make you transform from a data scientist from to a person that's really impacting and making good stuff for the company.
Absolutely.
And I think this kind of new label of a senior data scientist is not that close to being the best in deep learning or being the best in machine learning. I think is when you try to become a senior here in this area is when you know more about the business. It's,
Oh,
it's,
yeah.
it's like the
Yeah.
opposite here of being the best tech guy or the best programmer in the company. I of course it's important to have the technical capabilities to build all the things you're trying to do. But when you transcend that point of being the tech guy who understands some databases to that person who also knows the business a lot, is able to understand and hear people talk about it and
Yeah.
transform all of that ideas into actionable solutions for the company. There you can become a serious and a serious point, a
A
piece
go-to
for
person.
a
Yeah.
company you're working for. So
Exactly.
we have 15 minutes
Questions. Yeah.
before going into yeah, before going into the questions, I just want to finish this kind of things. I want to mention some libraries because I think people maybe wondering, hey, well, this is all so fun, but how can I do this in R or in Python? So I'm just gonna mention some of them so you can check them out and learn because there's a lot of free courses there where you can learn this. And I'm gonna start with R. I think R, even though Python has been really important last year and is improving with every month, I think in libraries and stuff, I think at this point the best libraries for data preparation are in R, and those are dplyr and the whole tidyverse. I think the whole tidyverse is an amazing like set of tools that you can use to get into from raw data to really amazing and understandable data. And all of these kind of different packages like tidyr like or dplyr or or table, all of these are amazing libraries that you should check them out and just look on the internet for tidyverse in R, and there are free courses there and a lot of information. I'm more close to the Python world, so I think the the best library out there in Python is Pandas. I think it's a really important library, and it's really actually a lot of the things that Pandas are improving is just trying to match and be there with R. And but what about big data? That's one of the things I get answer. I get a lot of questions that, I know Pandas and I know dplyr, but when I what if I have 1 terabyte of data that I want to clean? What should I do there? And I think right now the one of the best tools for doing that is both Apache Spark and the PySpark API. And I think the PySpark API is improving a lot. Every month, every 3 months, we have a new release of the API, and it has a lot of amazing transformation tools for big data. And the good thing about Spark is you can work with 1 byte or 1 terabyte, and the code will be the same. All that you need for Spark to work in a hardcore level is a cluster. And right now, I think one of the tools that I've been working is called Optimus. This can actually help you get from just raw data into really clean and important and successful data to do analysis with PySpark. So for resuming my point here, with R, the tidyverse, check that out. For Python, both Pandas and PySpark with Optimus. I think those are a really good starting point for you to get into data cleansing preparation and study from the beginning of your projects. Something else to add, Terry?
No, I think you answered it perfectly. I think in terms of pandas, it's interesting. This just one person is maintaining, or maybe the other guys are helping McKinney as well. But yeah, it's good. But just keep your intuitions also alive. There's a whole lot of really cool tools in on your Linux or Unix platforms like awk and grep and all that stuff. Those things. You can do a whole lot of very interesting things with data. So like TR kind of tools in which you are able to sort of also jumble text together and do interesting things. Remove the spaces and remove empty spaces, white noise, etc. in data. So just keep your intuitions also. It's what happens is when you start using a tool, you get into a locked on mode, and you just want to use that tool, and then you're not able to understand the answer that you're trying to solve, which is what the goal is. Just use any tool that is at your disposal, which you're good at. I don't know. It could be Ultra Edit. I know a long time ago, I've also used UEdit, those kind of tools to kind of start, organizing data and preparing it. So, but essentially, yeah, I think you can do a whole lot of stuff with pandas, and that's a good way to start. And you use your intuitions and start eventually combining other skills and ideas and tools to come and arrive to a cleaned, prepared, hopefully labeled data where you have removed every sort of strange of doubt about what you were doing with it and why you started normalizing, regularizing that information, image, audio, or just text. And then eventually, I think you should be able to get the answers. So I agree. We have 10 minutes. I don't know. I'm looking at my screen, so you see that I'm still struggling with trying to see what I can see here on my phone. I cannot see questions, so I don't know. Do you see questions?
Yeah. Most people are just talking, and that's fun because they're trying to solve their problems in the chat. So
Yeah.
I think one of the things that I think I'm reading a lot is about cleaning data. And one of the questions I see here is how can you deal with different kind of data like numerical data, categorical data, and and one of the questions I have here that is just appear is like, what is the best resource online to start learning pandas? And if you follow us, I tend to get this kind of post with on how to get started with X, how to get started with Python and stuff. And I think right now one of the best platforms for learning, and that's not that expensive, is Data Camp, Coursera, uh, EDX, Pluralsight. They all have amazing courses, and there you have to pay like $50 or $40 per month. So I think it's worth to invest in your education. And when you say $40, it's not that much money for getting that a lot of good information here. So there are a lot of good courses on Data Camp on how to study data with pandas, and I think that's a good starting point. And also, there are a lot of blog posts, YouTube videos, um, and I think the best way to learn here is to practice. Just download a Kaggle dataset or a mock dataset you have somewhere, or maybe if you work in a company and you will need to work with that kind of data, just download a sample of the data and just start messing out. It's like, I'm gonna try to understand if you don't understand LinkedIn, and I've seen a lot of people trying to ask questions now on LinkedIn and not on Stack Overflow, and that's really interesting for me right now because I did not expect that at all. People are trying to on like technical questions on maybe how to use a library on LinkedIn right now. So if we have the chance to see your questions there, we can help you too. So I think there's a really vibrant community, both in Stack Overflow, here on LinkedIn, or maybe actually on these old forums of Coursera forums or data camp blogs and on Medium blogs. So I think we're in an amazing time here to start learning both for free and for a small amount of money.
Yeah, I agree. I think today we are at a much better place than we were 10, 15 years ago. So I can tell you that, all that individual effort is now becoming more like a collective effort. I get a
Yeah,
whole lot of questions as well. For me, I mean, it's more of a cognitive load. I just am so busy and, waking up early in the morning and going very late in the night. I'm trying my best also to answer questions one on one. So agree. Any other
yeah.
questions?
I'm
Yeah.
seeing more questions about feature engineering. One of the things maybe you can just answer here is how to do feature engineering in solving data science problems.
Yeah, maybe you can answer that as well. I'm struggling a little bit with my laptop here.
Okay, yeah. So feature engineering, I think, is one of the most important parts in machine learning. And one of the fun parts of deep learning is that you don't need to do that as much as you did it before on machine learning. But right now, a lot of problems are solved with machine learning, with classical machine learning. And feature engineering is these steps of transforming one type of a column into a column that will work for you to work in a model. I'm just gonna give you a simple example. Most of the random forest or tree algorithms out there and their implementation only work with numerical data. For example, in Spark, you need to have numerical data to be able to run or work with a tree model. So feature engineering here will mean you need to transform your categorical variables into an index format or a numerical format to be able to fit that kind of data into the modeling process. But this is not obvious if you don't understand why is this happening. So I really recommend before just throwing data into a machine learning algorithm that you check the documentation and some examples. So you see why do we, because sometimes you get an error that you don't understand, and this error is because you're using categorical variables. So before just doing that, just go to the web page, see some examples, go to the GitHub, see the example section, maybe just write on your Stack Overflow example of random forest in PySpark or in R, and there you will have a good understanding on what do you need to do with to the data to be able to get to transform it into a point that you can use a machine learning algorithm with that.
Yeah.
So that's one of the things you do a lot with feature transforming, is trying to be able to actually use the data for a modeling process.
Yeah. Just
So yeah,
Yeah, just to add, yeah, I think you're right. Yeah, you said it also quite right. The problem is we should not just jump into process of feature engineering, but also understand that if there are like a number of features, or someone raised a question yesterday, and I answered in one of, I think one of the posts announcements about, having thousands of features, and then, then you have to ask yourself not just about the quantity, but also the quality. Which are the features that actually are not features? So it's more
yeah,
like a soft problem that you need to solve in your head before you start working with higher dimensions and trying to complicate your analysis, which is not necessary. So I would say, right, reduce it down and eventually use something like a PCA, principal component analyzer, to kind of reduce the dimensionalities, and then proceeding with the questions they need to answer. I think that's really key. And there's no need to make too complex kind of decisions and discussions around it. As technical people, we tend to do that a lot. So on one side, it's important to delve into the latest and the best methods to basically able to analyze and improve your features, etc. But I think also do a little bit of sort of checking and bunch of sort of brainstorming to understand how the quality as compared to the quantity of the features, and take a best sort of the model that you need to go and sort of create your deep learning or machine learning model. So yeah, I think,
yeah.
yeah.
So I'm gonna maybe go to one more question. And some
It's a pity that I
well,
cannot
first
see.
is
Yeah, I
there
cannot
any
see
tool
questions here.
for oh, sorry. So is there any tool for data cleaning? And I think we just mentioned them, and they're not specifically to do data cleaning, but they're used to do that. In R, the whole tidyverse is used for data cleaning, and in Python, Pandas, PySpark, and Optimus are maybe the tools that people are using for cleaning data. One of the good questions here I'm seeing right now, it's not that close to this, but it's a good question, is do we need to have solid statistical knowledge to be able to interpret the results of the algorithms, so we can understand whether the results are good?
Yeah.
I think a solid statistics is important for being a data scientist. Apart from understanding algorithms, and if your results are doing fine, I think statistics is one of the main branches and things you really need to master for being a data scientist. And the only way of actually testing if your model is working correctly is with statistics. We have a lot of different ways of doing that, and we have a lot of different metrics and you can just measure, but the metrics mean nothing if you don't understand them. So you really need to spend some time of your life trying to understand how to measure the accuracy of a model, because if you don't understand, uh, I mean, it can be a number, and hey, the closer it is to one, the better. And if you have 0.9, that's okay. And it's not only this is not the only thing you need to work with. You need to run a lot of different kind of statistical studies to find if first you have a good representation of the data, to see if you have a a solid estimate of what you were thinking or wanted to do in the beginning, and actually if the data that you're working with is comparable to other being done, if you're overfitting with the data. So I think understanding the metrics is really important just before trying to get the best accuracy ever.
Yes, also I think there is not much to add there. Like I said, I'm setting up the Google Hangouts on my laptop. It's the new laptop. It's just frustrating. I cannot see the questions. We
Yeah.
we we are past time. Maybe
Yeah.
if, just, is there any sort of other questions that yeah.
I'm seeing I'm seeing one, and that's a really good question. Is how we will choose best feature for a model. And I think there are a lot of good studies there. I just will mention the tools you need to do this. First, you need to get the information out of a variable, and you need to see if that variable actually about the data. And you can work with that with information value or Gini. Those are just words. Just check them out on the internet and read about them. And also, one of the important things there is weight of evidence. You can just check that out too on the internet, and those things will help you just trying to see which variables are the most important for your study. In the end, maybe when you create a tree model, most of the libraries will have a method that will return you the best or the most important variables that the model actually used to fit the model. So just look for like best features or best variables method inside of the machine library machine learning libraries, and I think you can get the best representative kind of information from your data. All right, Terry.
Yeah.
So I think we're out of time. I don't know if you have more announcements to make
Yeah,
or
I
something
guess,
about that.
yeah.
Maybe you can talk about that.
Sure. I think this was a great discussion. I think probably the most important discussion, or well, every discussion is important. Hyperparameter tuning and network parameter tuning, etc. Those are very important questions. We hope to bring those deep, deep, deep questions. Things sometimes we also make mistakes and make stupid assumptions. I make a lot of mistakes, and I think, oh man, I didn't think about it. So we're going to come back to that with you guys, and do some awesome stuff. One of the announcements is, the interesting thing that I want to share is that with Deep Kappa, I sort of shared some stuff with you, and some people were asking like, okay, hey, what is that? And is it a bunch of pictures you shared? What is that? Those 10-track program. So basically, while we do really interesting stuff in Coursera, and there are a bunch of trainings, I had this desire. Also, I've been in sort of in the education industry, worked and talked at the University of in the Netherlands as well. So we've been experimenting with MOOCs, or the blended kind of platforms for a long time, 15 years. I used to manage actually one of the sort of a rather famous kind of platform, online sort of a learning platform called Blackboard. I don't know if people ever heard of it in universities. Blackboard was a company founded by a bunch of young guys in the beginning of 2000, and they sold this product to every university in the world. That gave me ideas because I used to manage this large sort of a Java application and big sort of data, multi-clustered application, front and back end. Long story short, I thought there was a better way to do this. And in that time, MOOCs were not alive. There were platforms like Moodle. I don't know if people have heard of that name. And there was another platform which is called Sakai. I don't think I think it's still there. So Chuck used to be a guy who works right now and teaches at Coursera as well. So, but again, it's not solving the real problems. The thing is, the questions that you guys are asking, I know, I myself also know that, wow, I wish I had a great example to show, hey, listen, this is the way I do data, this is the way I process it, and this is what I'm doing. The best way to learn is to have this combination of online experience, which is inexpensive, but providing a classical way of learning, because the best way we learn, it's scientifically and neuroscientifically proven, is when you trust the next person in the room who wants to tell you things, the truths of whatever that is. Now Andrew is one of the greatest. I really love the way he teaches. His gentle approach reminds you, takes you immediately back to your favorite teacher. To me, it takes me back to my favorite history teacher back in, I don't know, when I was in grade 8. The gentle way of saying it's okay, it's no problem if you don't understand it. And I feel, oh, it's okay, I'm allowed to make mistakes, and I allow myself, because I don't feel that I'm somehow the best person or something anymore. That's great feeling, not to have that pressure. Anyways, with deep Kafka, what the limitations obviously which other traditional platforms have is, all the great things are coming up, but there are not learning sort of platforms that can take you to a higher level of learning. So I'm right now working with, there's a growing interest from industry and enterprises. So I'm creating this huge program in which, starting indeed from data wrangling and everything and going really deep into it, and providing a program which is for enterprise. So it's a proper classical plus a MOOC kind of a platform. What that would mean is we would need to raise capital, and it has to be a lot actually. We made some math, and it has to be in at least tens of millions of dollars. But I'm having some interesting conversations. So it would mean is answering a problem, for example, from a GPU perspective. It's people are not able to do things fast. People are not able to babysit or even do a bunch of other iterations. And then you end up just doing some baby sort of toy database learning, and then you don't go further. So my intention is to take it further and eventually raise enough capital to have a huge sort of subset of a data center where we can have thousands and thousands of GPUs, which will need obviously capital sort of to purchase that. And then taking the next step is to take reinforcement learning, generative adversarial networks in autoencoders, capsules, and other new emerging techniques directly to the market. That's the thing I'm thinking. I'm thinking the world we don't need to wait 5 years before we say, oh, now we can use capsules. Well, by then, I'm sure Jeff is going to come up with something else, Jeffrey Hinton, and then everybody will be start chasing that sort of a goal, which
Yeah.
is stupid. So
Yeah.
my goal is within 6 months, you have something, you try it, test it, and you see if it works. If it works, the whole industry will adopt it. And my goal is to bring it through Deep Kappa. So there are some really smart people I'm working with, and you see announcements. I'm announcing some PhD and postdoc people, but also anybody. I mean, even in engineers who want to participate in this. So the announcement is, yeah, it's what we want to do. We want to take it to a much higher level, but also to that level in which you enjoy that studio experience, in which you are really visible in your video. You're literally in your class. So I'm thinking of this sort of 360 degrees kind of a studio in which I walk into a class. Maybe I'll have Fav walking to the class virtually, and then we are sitting and sort of you're playing, and we have large screens, and you get that experience and you learn from it. So it's a big hairy sort of ambition, but I want to make it happen because it's something which I always believed in as a little kid. It's something that came back to me when I was working at a university and teaching at a university, and I was thinking that's not the way. Classical is boring. Online is so feels so distant and not real. There is a solution in between that is a blended learning. So that is the first announcement, and the next is, yeah, on the capsule network. Uh, it's I'm super excited to be embarking on one of the top medical colleges in Germany to use capsule networks and manifold learning, and that again reinforces my principles of if you have something new, why don't we work on it and test it? And this is great. It's a 3-year long project. So we'll do capsules, we'll do manifolds, we're going to do a lot of derivative maths and super interesting stuff. So, oh, great. I'm already seeing that my co-creator, he's just sending me a Skype message in China. Haodong Liao is the guy I've mentioned several times in my post. He's flying over right now. I just got his message on Skype. So he's flying over tomorrow, coming to Europe, traveling for the first time. So it feels so exciting, including talking to Fab and people all over the world, that we have a mission, and we are looking forward to make this huge with Eric, with Sarah, and hopefully more people. And my goal is to include these smart people into this platform where we can move into that next stage of not just talking, but doing stuff. And then from doing stuff, we will make a lot of mistakes. Believe me. I mean, and
Yeah.
I like to be very super sort of perfect, and I'm very punishing. I'm very punishing to myself when I make mistakes, and I'm not giving the right answer. But let's not worry about it, guys. It's okay to make mistakes. It's okay to make wrong conclusions as long as someone else says, "Hey, it's okay. No problem. Why don't you look at it this way?" I want to do that. So, well, that's and we want to include you. Who knows? I mean, we could end up doing something great together. I've spoken to Bo. I wanted Bo also involved in a bunch of projects that I'm doing. I'll fly you guys all over the place around the world. I'll fund you. I'll bring you, and God damn it, we're gonna fucking do it. you know.
Yes,
Oh, sorry, it's
yes,
morning. It's not the best way to start the day, but I'm we are super passionate. That's why we're sitting up in the late in the night or early in the morning, because it's an amazing field. It's a great area to improve your career. The last thing which I would like to say, Fabio, is also, besides the excitement, it's actually it's very hurting to me that a lot of people are struggling. People don't talk about it. I'm sure you have emails also. uh, I wish I could hold everybody's hand and say it's okay, it's going to be okay. Because a lot of people are looking for jobs and internships. I'm having a lot of conversations trying to
yeah,
bring
it's
people
really
into
hard.
that. Yeah, yeah. So I think
I
the
created a
reality,
post
yeah,
today about that. Actually,
yeah,
it was about frustration.
yeah,
I see a lot of frustration right now in the area, and I think one of the reasons there is sometimes the job offerings are really weird. I
yeah.
mean, there are like, yeah, I need someone to have 10 years of experience of machine learning. Where will you find that?
It's
I have
ridiculous.
no
Yeah.
idea where would you find like Andrew and G is your only Andrew and G is your only kind of employee, so it's not easy here.
No, no. I guess yeah. They should all go and ask him. I think it's not a laughing matter. I think
So
yeah, yeah. Sorry, there was a little bit of interruption, but I agree with you totally. It's no laughing matter. This is serious. It's about lives. I know people. I'm having conversations with people. Sometimes the people are coming into tears. I have online video conversations. It breaks my heart. I and I'll just leave you guys with just one simple example. I migrated to the Netherlands in 2000. I had just 5,000 guilders in my hand. I mean, this is reality. It's also published in some interview I gave to Al Jazeera a few years ago. All I'm trying to give you is, I'm not trying to pretend to be a hero or anything. It's about, I had no idea what to do. I had to learn a totally new language in the Netherlands. I mean, I'm born and brought up in India and traveled around the world. And eventually, at the age of 28, sometime long time ago, I won't tell you what my age is. I'm older to these guys, but these young, smart people. But I had no job. It was back in the days when, just a year before 9/11. So it was market was still quite scary. Internet boom or bust had happened, and here Mr. Singh comes to a country with 5,000 guilders, which is 2,200 euros in his pocket. No language, no skills, zero, zilch, nada, nothing. I just started making phone calls. I said, I don't care if I get a job as a plumber as long as I can still continue my dream. And that's what I meant last time as well. Don't worry about it, because things will come around, and it seems almost difficult. You almost feel like giving up. So I want to give this motivator before moving on. I still experience frustration, and the only thing is just sort of think of the times where I look back and say, wow, you went through, you did it. So I learned the language. I also got my first job. And it was not a high-paying job, so I was totally okay. I was just happy because I was able to do nice things, and I started implementing, because that little gene inside you to solve that problem mathematically or programmatically will never go away. So don't worry, and that is cool. Yeah,
Yep, and I always say like this is like a you need to be strong here, and it's not easy to get rejections because we got a lot of rejections, and maybe people just doesn't give you anything. Like you apply for 500 jobs and you have one reply. So don't worry, you'll get there. Keep applying. Keep it. I mean, keep it clean. Let's keep having fun, and you will learn from every mistake here. And
yeah,
if you're lucky enough, as I say today on my post, if you're lucky enough, you'll get a recruiter that will tell you the flaws, your flaws, and that's the way to start getting better. It's understanding where you're not great and understanding how to improve that. So I think if you take all of this criticism and rejection and transform it into actions and into learning and into passion, I think you'll get the job really soon. So
Yeah.
don't
Yeah.
don't get frustrated. It will happen, and I hope we can help you in the process.
Yeah.
So Terry,
That's yeah.
I think we should be saying goodbye now. And thank you guys, all of you guys for being here and all the people that will see the video after. And we are very happy to answer all of your questions. Sometimes it's impossible. Sometimes we get a lot of messages. It's not personal. When we don't answer,
But
it's
keep them
really hard
coming.
to.
Keep them
Yeah,
coming.
keep it coming, keep it coming, keep it coming, and we'll try our best to answer all of you. So um, so yeah, keep learning, keep having fun, and we hope seeing you next time again.
Awesome.
Bye
Have a
bye,
great day,
bye guys,
guys. Yeah, and have a
bye.
great weekend, the coming weekend. Awesome.
You too. Bye.